6.3, number 35, it says integrating inverse functions. Assume that the function f has an inverse. First thing we're going to show is that this is equal to this. And they give us a hint that y is the f inverse of x. So then you could do f of each side. And on the left side you would have f of y, and f of f inverse of x is just x. Focus please. It's not very focused. Alright, so now we could find the derivative. Derivative of f of y is f prime of y times the derivative of the inside, which is dy dx, and the derivative of x is 1. So we could solve for dx, and it's f prime of y dy equals dx. So back to what we're trying to figure out this. It's the integral of f inverse of x, which is y, times dx, which is f prime of y dy, right here, and that's what we got. So part A complete. We showed that this integral is equal to this, and now we're going to use integration by parts to kind of evaluate this. This whole thing is just pretty abstract, kind of proving that integral of f inverse of x is equal to whatever we get when we find the integral of this, because that's the same as this. So we're just kind of dancing around functions and their inverses and creating another equation that this is going to be equal to whatever we get when we integrate that. So that's part B. We're integrating y f prime of y dy. So I'll choose my u to be y. And my dv to be f prime of y dy. Derivative integral of f prime y is just f of y. So u, which is y, v f of y, minus integral of v f of y du, which is dy. Okay, and we do have some substitutions for y. Y we said was inverse of f inverse of x, and f of y is x. So if this is x and that's f inverse of x, we could rewrite it as x f inverse of x minus integral of f of y dy. So this is, we started with this and we changed it to this, and we integrated it, evaluated, and you end up with this. So transitively you could say that the integral of f inverse of x is equal to x f inverse of x minus integral f of y dy.